In this slide, we will see in deeper about the real world examples of software maintenance so that you can easily understand what we have learned in the previous slides. To truly understand how widespread and essential software maintenance is, let's look at some examples you interact with every single day. First one is the operating systems. Think about the operating system on your laptop or a phone. Microsoft releases regular Windows update patches that address security vulnerabilities and improve performance. These updates are a mix of corrective maintenance, which is fixing bugs, and perfective maintenance, which is making the system more efficient. This ongoing effort is crucial for protecting users from new security threats and keeping the system running smoothly. Now you understand about the corrective maintenance and the perfective maintenance. Then the second example is web applications. Online platforms like Amazon or Flipkart are in a constant state of maintenance. They undergo frequent adaptive maintenance to handle new payment gateways, comply with the new government tax regulations, or scale up to handle massive traffic surges during seasonal sales. This continuous work ensures the platform remain functional and legally compliant in dynamic economic environment. The next comes the mobile applications. The apps on your smartphone are perfect example for continuous maintenance. I have already gave so many examples using WhatsApp. You have always using WhatsApp. Now we can see the Instagram application, for example. Instagram releases weekly updates that add new features like reels or new filters. This is a clear case of perfective maintenance, enhancing functionality based on user demand to keep the application engaging and competitive. The next is the critical systems. On a much larger scale, consider a software for critical systems like those used by NASA. They maintain spacecraft control software for decades, even rewriting parts to adapt to new mission requirements or new ground systems. This is a mix of all four types of maintenance, often for systems where a single bug could be catastrophic. This demonstrates that maintenance is not just a commercial software. It's just a fundamental part of keeping high stakes, long-lived system operational. We'll move on to the next slide. To ensure effective and cost-efficient maintenance, organizations follow a set of best practices that transforms maintenance from a reactive core into proactive strategic activity. The first best practices is maintain high quality documentation. The second one is embrace modular design. Third one is use version control. Fourth one is implement automated testing. Fifth one, practice regular code refactoring. I will explain in detail all of this. The first one is maintain high quality documentation. One of the most valuable assets for maintenance team is up-to-date documentation. Maintaining clear design documents, API specifications, and code comments from the very beginning saves countless hours of reverse engineering later on. The second one is embrace modular design. By writing code in independent, self-contained modules, developers make future changes much easier. A modular design allows a maintainer to modify one part of a system without affecting the entire code base, reducing the risk and complexity of the changes. The third one is use version control. Tools like Git are non-negotiable for modern software development and maintenance. They track every change made to the code base, allowing a team to collaborate safely and, most importantly, providing a way to roll back to a previous stable version if a new bug is introduced. Fourth one is implement automated testing. Automated tests are a maintenance team's best friend. Automated unit and integration tests run quickly and repeatedly, providing a safety net that immediately flags if a new change has broken existing functionality. This practice is a vital for reducing the risk of introducing new defects during maintenance. And finally, practice regular code refactoring. Finally, a key best practice is to treat maintenance as a continuous activity. By scheduling regular periods of code refactoring, teams can perform preventive maintenance. This proactive cleanup improves the long-term health, readability, and maintainability of the code base, making future works easier and cheaper. By following these practices, organizations can dramatically reduce the cost and complexity of maintenance, ensuring their software remains a valuable asset for years to come. We'll move on to the next slide. So now, to summarize this lecture or to summarize this concept, let's recap the key takeaways about software maintenance. First, remember the definition. Software maintenance is the essential, ongoing process of modifying software after delivery. Its purpose is to fix defects, adapt to new environments, or enhance functionality. Second, it's a continuous and costly process. We have learned that maintenance can represent the majority of a software project's total lifecycle cost, often consuming 60% or more of the budget. Third, when dealing with older systems, reverse engineering is a vital technique. It helps us create a blueprint of a system when the original documentation is missing, allowing us to understand and safely modify the legacy code. Fourth, maintenance is not just a chaotic mess of bug fixes. It's a structured process that can follow the specific models like quick fix, iterative, spiral, and reuse-oriented models, each suited to different project needs and risk levels. Finally, we have covered that cost estimation is influenced by several factors, including the software's size, its complexity, and the frequency of required changes. In short, software maintenance ensures that our software remains reliable, secure, and valuable to its users for years after its initial deployment. It's the crucial work that keeps technology relevant and functional in a world that is always changing. Thank you so much.